user mode. So in this session we can extend the concept process management, storage management, memory management, these all things. So already we know what is process. Actually, a process is a some small part of the execution. So it may be anyone. So either it may be program execution, it may be any system call execution, it may be any task. So here by simply process is a some program execution. So actually here whenever we are executing anything, so to execute that particular process or that particular program, for that purpose we are using the one more program. So this program is responsible for executing the that specific process or that specific task. So in this process to continue or to complete that particular process, for that purpose here operating system is responsible for performing the some unit of work. So that is majorly depending on two things. One is the program and another one is the process. So here this program is responsible for executing the some process, and here process means to complete the that particular execution. So that's why here that particular program, whatever the program we are developed, our operating system was used to executing anything. So that program is some passive entity and the original execution process is the an active entity. So here to perform any process execution, so for that purpose here operating system needs some resources to complete the any process execution, so which may be small process or large process or anything. So to it requires some resources. What are such resources means? Either CPU, memory, and IO, and some files. So these are the major resources was used to execute any process execution. So here those resources are CPU. CPU means nothing but here processing unit, that is the processor, and memory, so to store and retrieve the data to complete that particular execution. So for that purpose we are using the memory, so it may be any memory, and IO files to getting the input and to processing that particular input and finally produces some output. So for that purpose we are using the IO, and finally to store and retrieve the data from one memory location to the another memory location, or to open any specific data. So for that purpose we are using the some file. So this file is responsible for either open some information or close or update some existing information or read any existing information or modify any information. So for that purpose we are using the several file operations like opening a file, creating a file, removing a file, either updating a file or writing a file. So in this manner, so these all operations should performed with the help of files. So these are the some basic resources to complete the any process execution by operating system. So in this process, so after completion of the any process execution, so here operating system is the responsible for terminating that particular process. So why? Because in case so that operating system was not terminating completed processes, means what happened? So here that CPU availability or CPU time was not able to used by the any other process. So that's why here after completion of the any process execution, here process termination is mandatory. So why we are terminating the currently running process means, so to reuse such resources by the any other process. For that purpose we are terminating every process after completion of it. So that's it. And in this process while we are going to executing anything, so in this process, so that is this execution process is depends upon the process structure. So in case it may be single threaded process, or in case it may be multi-threaded process. So in single threaded processes, how it was executing that particular process means, so in single threaded processes it was using the only one program counter. It was using only one program counter. So this program counter is responsible for getting the next instruction information. So while we are executing currently some program for getting the CPU next instruction, so for that purpose we are using the program counter. So in case we are using the multi-threaded processes, at that situation for each and every thread it was separately maintains the multiple program counters. So why it was maintained multiple program counters means multi-threads or multi-cores was performing their executions parallelly. So for that purpose, after completion of the current instruction, it required to allocate any other process. So for that purpose, we are using the several program counters. So that is simply in case we are using the two threads, then two program counters will require. In case we are using either four cores or four threads, then it require four program counters. So in this manner. So this is the process of performing the process management. What is process and how to executing the process, and for completing the any process
Yeah,
what.
that screen is not displayed, sir.
Okay, okay, no problem. I will display it. Okay, either what is the process and how to create the process and how to execute the process, and to execute any process whatever the resources was required for the any process, and how to handle process execution in single threaded cpu and multi-threaded cpu. So these are the details about process management. So in this process, that means while we are going to handling the any process at that situation, whatever the several activities can perform by the operating system. So that is simply to executing the any processes. For that purpose, what is the goal or what is the role of the operating system? So here actually operating system is responsible for several activities. So that is to creating the some process and to deleting the some process. So for that purpose here operating system is the responsible. So that means so here operating system can able to create some new process, and it can able to it can delete some existed process after completion of that one. That is nothing but termination. So and here operating system is also can perform either suspending the some process or resuming the some process. So already we know, just know already we know the some basics like how to what is meant by creating and what is meant by removing or deleting. So here creating means nothing but simply creating the some new process for perform some specific execution, and deleting means after completion of that particular process execution to allocate that cpu time for the another process. For that purpose it was removing the completed processes. So that is the deleting. And suspending, so suspending means in case for example currently cpu was running some process p1. So to complete that particular process, so it requires some resources. So in case such resources was currently not available, just assume some of the resources not available for completing the process one. At that time operating system is responsible for temporarily suspending that current executing process. So and after available of their required resource, so in case process 1 needs either resource a, so currently such resource is not available, at that situation operating system can suspend the that particular process. Here suspending means nothing but currently pass their execution, currently passing the that particular process execution. And after available in case that particular resource a is available after some time, in case that particular resource is available after some time, so then here operating system is responsible for again resuming the previously suspended process for execution. So this is also another responsibility or another activity of the operating system. And here Operating system can also perform process synchronization. Operating system is also responsible for performing the process synchronization. So here process synchronization means, for example, when we are going to executing multiple processes by using the single CPU. At that situation, here operating system is responsible, or operating system can able to performing those three processes without any difficulties. సో అంటే ఏంటి, సో ఇన్ కేస్ ప్రాసెస్ వన్ కంప్లీట్ కావాలి అంటే ఇన్ కేస్ ప్రాసెస్ టూ ఈజ్ రిక్వైర్ అనుకోండి. సో అండ్ టు కంప్లీట్ ద ప్రాసెస్ టూ దెర్ వాజ్ నో డిపెండెన్సీస్. ఆఫ్టర్ దట్ ప్రాసెస్ త్రీ ఈజ్ ఆల్సో ఇండిపెండెంట్. అంటే we want to perform three processes, just assume, just our assumption. So we want to perform three processes. So for that, those are p1, p2, p3. So here p1 and p2 are dependent processes. అంటే టు కంప్లీట్ ద p1 we need the help of p2, అంటే p2 నుంచి some resource కావాలి మనకి. And to complete the p2 there was no dependent on p1 or p2. And next, p3 is also independent process. P3 is doesn't require any resources from the process 1 and process 2. So at that situation here here operating system can able to synchronize those process execution in some specified manner. So based on our assumption, here p2, p3 are the individual processes, and those are doesn't depending on the any others. That's why it can schedule either p2 first or p3 first. After completion of the p2 only it can schedule the p1. So such kind of activity is also performed by the operating system. And here operating system is also responsible for performing the process communication, and while we are going to performing any process execution, so for that purpose here operating system can able to communicate with such processes. So in case which process wants to execute at current time, or which process was currently not available some resource, which process was currently not able to complete. So such kind of communication information can be gathered by the operating system. So based on that communication it can schedule any other process for execution, or it can suspending any specific process temporarily. So any process can be resumed. So such kind of activities can be performed based on this information. And here CPU operating system is also responsible for avoiding the deadlock or handling the deadlocks. So already we know what is meant by deadlock. So here deadlock means nothing but it's some conflict situation or complicated situation to handle that particular process's execution. So that means whenever operating system was trying to execute more than one process simultaneously, at that situation it can't able to, so due to some problem, so it can't able to execute those processes simultaneously. That situation is known as the deadlock. For example, we want to perform, either we means nothing but we are the operating system now. So now we want to perform two processes execution, those are p1 and p2. So now we are the operating systems. Now we want to perform two processes execution. So for that purpose process 1 needs two resources and process 2 needs two resources. Those are process 1 require a b, ఆ రెండు రిసోర్సెస్ కావాలి to complete the process 1 execution. To complete the process b execution or process 2 execution, it requires again two resources. Those are resource 2, resource 3. That means resource b, resource c. So process 1 complete అవ్వాలంటే ab కావాలి, process 2 complete అవ్వాలంటే bc కావాలి. So here process 1 2కి 1కి డిపెండెన్సీ లేదు కదా, డిపెండెన్సీ క్రియేట్ చేయాలి. Okay, right. So we have one more process, that is process 3. So it was also require two resources like resource c, resource a. Process 1 is ab. Wait a second. So this is p1 and this is p2 and this is p3. So now operating system was trying to execute these processes simultaneously. So here this p1 requires two resources, those are a, b, and process 2 needs two resources B and C, and process 3 needs two resources C and A. So here just assume our assumption. Here process 1 is hold A, అంటే రిసోర్స్ ఏని హోల్డ్ చేస్తుంది. హోల్డ్ మీన్స్ నథింగ్ బట్ దట్ పర్టిక్యులర్ రిసోర్స్ ఈజ్ నాట్ యూటిలైజ్డ్ బై ది ఎనీ అదర్ ప్రాసెస్ అంటిల్ కంప్లీషన్ ఆఫ్ ది P1 ఎగ్జిక్యూషన్. ప్రాసెస్ 1 ఎగ్జిక్యూషన్ కంప్లీట్ అయ్యే వరకు రీసోర్స్ ఏని ఇంకా ఏ అదర్ రీసోర్స్ ఏ అదర్ ప్రాసెస్ కూడా యాక్సెస్ చేయలేదు. దట్ ఈస్ నథింగ్ బట్ హోల్డింగ్. So and to complete the process 1 it requires resource B. So here once again, so these are the resources, so these are the processes. P indicates the process and ABC are the resources. So P1 is holding the resource A and wait for the resource B, and here P2 is holding the resource B and wait for the resource C. Here P3 is holding the resource C and wait for the resource A. So now which process can be completed first? So is it possible process 1 complete అవ్వాలంటే B రిసోర్స్ కావాలి, కానీ B రిసోర్స్ని ప్రాసెస్ 2 హోల్డ్ చేస్తుంది. ప్రాసెస్ 2ని కంప్లీట్ చేద్దామంటే రిసోర్స్ C కావాలి, రిసోర్స్ Cని ప్రాసెస్ 3 హోల్డ్ చేస్తుంది. సరే ప్రాసెస్ 3ని కంప్లీట్ చేద్దామంటే రిసోర్స్ A కావాలి, రిసోర్స్ Aని ప్రాసెస్ 1 కంప్లీట్ చేస్తుంది. సో నౌ we can't able to execute any process. So this kind of situation is called as deadlock. So here operating system is also responsible for handling this type of situations. That is nothing but deadlock handling. We will discuss later how to handle the deadlock, these all things. So okay, anyhow, so these are the activities of the process management. Next, memory management. So already in last session we was discussed what is memory, how to whatever the notation was used for representing the memory, like bits, bytes, kilobytes, megabytes, gigabytes, and petabytes, sorry, terabytes, after that petabytes. So now we observe how to performing the memory management. So here whenever we are going to execute any instruction or we want to execute any process, so for that purpose we must need to store that particular instructions into the memory. అంటే ఒక ఇన్స్ట్రక్షన్ మనం ఎగ్జిక్యూట్ చేయాలి అంటే ఫస్ట్ ఆఫ్ ఆల్ దట్ పర్టికులర్ ఇన్స్ట్రక్షన్ కెన్ బి కాపీడ్ ఇన్ టు ది మెమరీ, దెన్ ఓన్లీ ఇట్ కెన్ ఏబుల్ టు ఎగ్జిక్యూట్ ఇట్. సో ఫర్ దట్ పర్పస్ ఇట్ మే బి కాపీ ఎంటైర్ ఇన్స్ట్రక్షన్ ఆర్ సమ్ పార్ట్ ఆఫ్ ది ఇన్స్ట్రక్షన్. మనం స్టార్టింగ్ ఇంట్రడక్షన్ క్లాసెస్లో డిస్కస్ చేస్తున్నాం అట్ ఫిజికల్ క్లాసెస్. సో ఇన్ కేస్ నేను 32-bit ఇన్స్ట్రక్షన్ సిపియు యూజ్ చేస్తున్నాను, whenever instruction size is more than 32-bit, then we can able to that particular CPU can able to handle or not. So is it handle or not? So it was obviously handle. ఎలా హ్యాండిల్ చేస్తుంది మోర్ దాన్ 32-bit ఉన్నప్పుడు? సో ఇట్ కెన్ డివైడ్ దట్ పర్టికులర్ ఇన్స్ట్రక్షన్ టు సబ్ కేటగిరీస్, sub instructions, and then handle each and every sub instruction at a time. After handling these all sub instructions, then combining the result and produce the output. So in this way, so that's why whenever it was having more length, then it can copy some part of the instruction. After completion of that, again copies some other part of the instruction. So in this way, so it can able to execute any program. So for that purpose it must be copied into the memory, either entire part of the instruction or some part of the instruction. So in this process here memory management is responsible for when it can be copied into the memory and when it can release it from the memory. So that is the major responsibility of the memory management. So why sir, why it was copied some information and why it was released such information from the memory means to effectively utilizing the those memory by the other processes for that purpose. So now we observe whatever the memory management activities. So here this memory management is responsible for tracking the whatever which part of the memory was accessed by the which process at which time. So currently which part of the memory is accessed by the which process and when it will be released, such kind of information was maintained by the memory management. So and next, so it was also decides which process can be handled and which data can be moved from the memory. So that means, so here memory management is also responsible for deciding the at currently which process can be handled by the CPU, and their data can be moved from the one memory to the another memory. So such kind of activities is also performed by the memory management. And here memory management is also responsible for allocating and deallocating the memory space. So whenever such processes was required, so this is also another responsibility of the memory management. So these are the major activities of the memory management. So now we observe how to sorry what are the responsibilities or how to managing the storage. So here actually while we are going to executing any process by the operating system, so already just now we was discussed at the beginning of the session. Here operating system was performing some unit of work. So such unit of work or such several sub processes can be performed without any complications, right? So for that purpose here operating system can perform some uniform and logical view of the information storage. So here it can not giving any highest priorities for any specific process, or it doesn't give lowest priority for any other process. So such kind of variations was not given by the operating system, not performed by the operating system. So it was taking the equal priority or equivalence of the each and every process completion. So for that purpose here operating system or storage management is responsible for hiding whatever the process to store the data, whatever the process to retrieve the data from memory. So such entire process was abstracted by the storage management. So here we are simply just copy information or moving the information only. So how it was copied from one memory to another memory, how it was moved from one memory to another memory. So such kind of entire activity was abstracted by the memory management, sorry, storage management. And here each medium is controlled by the some specific device. So that may be in case that is depending upon the used memory. So in case we are using a disk memory, then disk drive is the responsible for handling the such entire data transmission. In case we are using any magnetic tapes, then that magnetic tape drive is the responsible for handling the such entire data processing or copying the data from one memory to another memory. So here these data transmission or storage information storage was depending upon the several things already was discussed at the time of cache memory or memory hierarchy. So that is depending upon the speed, cost and capacity. So based on how much amount how much data can be transferred within second, and what is the capacity of that particular storage, and how much cost of that particular memory. So based on these things here each and every device is controlled by the storage management. So now we observe whatever the several activities of the storage management. So here this storage management is responsible or can able to create and deleting the files and directories. So here this storage management can able to create any new file or remove any existing file, and then also any directories also. Already you know whatever the basic differences between the files and directories. Here file is a some small memory sorry here file is a some collection of instructions or some collection of data, so that is a file. And a directory means a collection of files. For example, directory means nothing but some folder. So here folder having some number of files, file having some specific information. For example, student result file, so it was having only information related to the student's result. So in case student attendance file, it was having the only information about attendance of the students. But what about the folder? So it contains every details about the that particular student or that particular session of the students. So in this way. So and here this storage management is also responsible for manipulating the files and directories. That means moving or copying from one memory location to the another memory location, or one file to the another file, or one file to the another directory. So such kind of mapping or manipulation is also performed by the storage management. And here the storage management is also responsible for copying the data into secondary storage also. So whenever we are processing the data on primary storage, after completion of those process execution, it can able to copy their modified values into the secondary storage also. And here storage management is also responsible for backup the files from volatile memory to the non-volatile memory. So that is nothing but from primary memory to the secondary memory. So these are the responsibilities of the several responsibilities of the storage management. So now we observe how we are maintaining the mass storage. So here mass storage means especially whenever we want to store some information up to some period of time. So that is nothing, that kind of storage is known as the mass storage. For example, we can use several disks like magnetic disks or magnetic tapes are used to storing the mass storage. So that means whenever we want to permanently store such information in some devices, for that purpose we are using the mass storage. So whenever we want to access that particular data, at that situation we can copy such information from the such magnetic tapes or magnetic disks to the some another memory for processing. So in this process it require some proper management of central importance. So here especially why we can maintaining the some proper management of the mass storage means, so that particular data, some data, if we want to store some information, so that particular data was maintained in several copies. అంటే హార్డ్ డిస్క్లో స్టోర్ చేస్తున్నాము, సమ్ మ్యాగ్నెటిక్ లేదా ఆప్టికల్ డిస్క్లో స్టోర్ చేస్తున్నాం, జస్ట్ అజ్యూమ్. సో అట్ లేదు వీఆర్ స్టోరింగ్ ఇన్ సర్వర్ మెమరీ అండ్ వీఆర్ ఆల్సో స్టోరింగ్ ఇన్ క్లయింట్ మెమరీ. సో అట్ దట్ సిచ్యువేషన్ వెన్ ఎవర్ దట్ పర్టికులర్ ఫైల్ వాజ్ కాపీడ్ ఇన్ మోర్ దాన్ వన్ లొకేషన్స్, అప్పుడు ప్రాబ్లం ఏంటి? సో వెన్ ఎవర్ వీఆర్ పర్ఫార్మింగ్ సమ్ మోడిఫికేషన్స్ ఆన్ దట్ పర్టికులర్ డేటా, దెన్ those modifications can be reflects on the all storages. టూ ప్లేసెస్లో స్టోర్ చేసాము. సో ఆ పర్టికులర్ డేటా మీద ఇన్ కేస్ వీఆర్ పర్ఫార్మింగ్ ఎనీ స్పెసిఫిక్ మోడిఫికేషన్స్, సో ఆ మోడిఫికేషన్స్ అనేవి ఆ పర్టికులర్ డేటాని మనం ఎక్కడెక్కడైతే స్టోర్ చేస్తున్నామో అన్ని లొకేషన్స్లో కూడా ఆ మోడిఫికేషన్స్ అనేవి పర్ఫామ్ చేయగలగాలి. సో దట్ ఈస్ ద వన్ మేజర్ యాక్టివిటీ. And here while we are going to using this mass storage, their speed, their accessing is totally depending upon the their related algorithm. So based on the which memory system, which algorithm was used in such memory, so depending upon these their performance or their speed will be depending. So in this process whatever the operating system activities means in mass storage management purpose, so those are free space management, storage allocation and disk scheduling. So these are the several activities of the operating systems in mass storage management. Free space management means it can able to clearly maintain how much amount of free space is available for storing the data. And storage allocation means it can clearly, it can able to store such particular information in some specific memory location. And disk scheduling means, and whenever we are going to retrieving or accessing that particular data, at that situation it can able to schedule that particular memory location or that particular memory track to access the data. And here whenever we are going to accessing the data, at that situations some storages may not providing such data access was fastly. So for example whenever we are using the memory devices like as magnetic tapes or optical storages, at that situation so we can't able to store or we can't able to retrieve fastly such information. And in case any specific data storaging or data retrieving is managed by the operating system, or any other applications. At that situation also we can't able to access such information very fastly. It was actually this was while we are going to accessing the data, their accessing speed is also depending upon the that particular data is read only or write also. So that means that particular file or that particular data can be accessed in which mode, either write once or read many times or read and write. So that means we can performing we can store once into memory, then we can use number of times. That is nothing but write once and read many times. And read and write means we can performing the read operation and write operation simultaneously. So depending upon these activities or these modes also, here storage access will be changed. These are the details about the mass storage management. So now we observe whatever the several levels of mass storages, and how to their information, like what is their capacity, how much amount of storage is available, what is their access speed, and it was managed by which one. So these all things, for example, these are the several levels of memories. So this is the level 1 and level 2, level 3, 4 and 5. So here level 1 memory is registers. Level 1 memory is register memory, and level 2 memory is the cache memory. Level 3 memory is the main memory, and level 4 is the SSD, level 5 is the HD. That's not HD, HDD. So already was observed in memory hierarchy. First memory is the register memory, next cache memory, and next main memory, and next SSD, and next HDD, and next hard disk memory. So here whenever we are using the register memory, now check out their details in vertical manner. So these all details belongs to the register memory. These all details belongs to the cache. These all details belongs to the main memory. These all details belongs to the SSD. These all are belongs to the magnetic disk. So here approximately how much amount of size of register memory is available means at maximum 1 KB. So of course nowadays it can available maybe 10 KB also. Actually these data calculations was approximately as per 2013 or 2016. సో అప్పటికి అవైలబిలిటీలో ఉండే టెక్నాలజీని బేస్ చేసుకొని వాట్ ఎవర్ ద టిపికల్ సైజ్ ఆఫ్ క్యాచ్ మెమరీ అవైలబుల్, రిజిస్టర్ మెమరీ అవైలబుల్, మెయిన్ మెమరీ అవైలబుల్, SSD and hard disk. So here available register memory is 1 KB only. Here which type of technology, whatever the technology was used in this means that is the CMOS technology. CMOS technology. And what is the access time of the register memory means we can access whatever the data available in register memory within 0.25 to 0.5 nanoseconds, not in seconds. 0.25 to the 0.5 nanoseconds. Their bandwidth, that means how much speed we can access, from 20,000 to the 1 lakh megabytes per second, that is approximately 20 GB to, that is approximately 20 GB to 1 TB. So such amount of bandwidth can be accessed per second. Within a second we can access up to 20,000 MB per second minimum, megabytes per second, at max 1 lakh megabyte per second. So it was managed by the compiler. So in this manner, so here typical size of the cache memory is approximately 16 MB, and here technology is also CMOS RAM, and their accessing time is greater than the register memory. Here register memory is the 0.25 to 0.5, but here cache memory is the 0.5 to 25 nanoseconds, and main memory is 80 to 250 nanoseconds, and SSD is 25,000 to 50,000 nanoseconds to accessing the data, and hard disk is 5 lakh nanoseconds. So these are the variations, and their available memory is SSD is up to 1 TB and HDD is up to 10 TB. So nowadays we can access, SSDs was available more than 1 TB also. So these are the several details about the several performance variations of the storages. So now we can observe how in this process, that means we are using, just now we was discussed different levels of storages, right? And their accessing speeds and their typical sizes, these all things. So now we can observe how that particular data was moved from one memory to another memory, or while we are going to accessing that particular data at that situation, how it was available for execution. So those things now we will discuss such one. For example, if you want to execute some instruction or some program, so actually we are storing our programs into which memory? Hard disk memory. So when we are, for example, now I want to execute some C program like uh, addition of two numbers. So now I want to execute some simple C program, it perform the addition. So for actually that particular addition program was stored in the hard disk in C partition, that means local disk C, TC, bin. So this is the, in this way some path. So we are stored in the secondary storage, that is hard disk. So whenever I want to execute that particular program, what is the process? First of all, I can perform the compilation. So while we are performing the compilation in this process, what happened means, so at that particular data was copy, not only compilation, whenever we are open that particular file to execution or to compilation. So once we are double click or we are choose to open that particular file, immediately what happened? That particular program was copied from the secondary memory, that is hard disk, to the main memory. అంటే హార్డ్ డిస్క్ నుంచి ర్యామ్ మెమరీకి మూవ్ అవుతుంది. ఫర్ ఎగ్జాంపుల్ ఇఫ్ యూ వాంట్ టు ఎగ్జిక్యూట్ సమ్ ఇన్స్ట్రక్షన్ ఏ, సో దట్ ఇన్స్ట్రక్షన్ వాజ్ కాపీడ్ ఫ్రమ్ హార్డ్ డిస్క్ టు ది మెయిన్ మెమరీ. సో ఆఫ్టర్ దట్ it was moved from main memory to the cache memory. After that it was moved from cache memory to the register memory. Why sir, why it was moving from one memory to another memory means, finally whenever we are going to execute any instruction, that particular instruction, to execute that particular instruction, it must be use register memory only. So then only it can able to complete their execution within some proper manner. So for that purpose, so in case that particular data is available in register memory, then we can directly execute it. In case not available, then getting from the cache memory. So here also not available, then getting from the main memory. Here also not available, then getting from the secondary memory. So in this way, we are moving or migrating that particular data from disk memory to the register. So these are the details about some storage environment. That's it. In next session we can discuss computing environments.